तर अब सबैलाई शिक्षाको अधिकार छ यो हाम्रो नेपालमा।
उद्देश्य के लिनु उडी छुनु चन्द्र एक।
क्षितिज पारी योगेश्वर अमात्य साथ कार्यक्रम भाग 3 अन्तर्गत यस भिडियो कन्टेस्टमा हामीले 6वटा भिडियो प्राप्त गरेका छौँ। उत्कृष्ट भिडियो छनौटको लागि 6वटा भिडियो हेरिदिनुहोस् होला र आफूलाई उत्कृष्ट लागेको भिडियो कमेन्ट बक्समा लेखिदिनुहोस् होला।
र हाम्रो सबिन भाइ रकेट प्रिपेरेसनमा, यहाँ अर्को साइन्टिस्ट भाइ बसेको छ। भाइ के चलिरहेको छ यहाँ भन त भाइ? त्यहाँ अर्को भाइ छ।
तिम्रो नाम के हो भाइ? मेरो नाम आशिष।
रकेट बनाउन लाग्यो आशिष भाइले हामीलाई सिकाइरहेछ है त। यो
नमस्कार, म बाजुराबाट रामचन्द्र सुनार। मैले यो चाहिँ मोबाइलबाट गरेको एस्ट्रो फोटोग्राफी हो। मैले खगोल विज्ञान अध्ययनका लागि अति नै उपयोगी क्यालेनोमिटर बनाएको छु। त्यो क्यालेनोमिटरले चाहिँ हामी कुनै पनि वस्तुको एङ्गल अफ एलिभेसन अर्थात् 49 कोण पत्ता लगाउन सक्छौँ। हामीले 49 कोण पत्ता लगाइसकेपछि हामीले पढेका साइन, कस र टेन थीटालाई चाहिँ हामीले व्यावहारिक जीवनमा उतार्न सक्छौँ। अहिले म चन्द्रमाको एङ्गल अफ एलिभेसन पत्ता लगाउन गइरहेको छु। चन्द्रमाको एङ्गल अफ एलिभेसन पत्ता लगाउनका लागि मैले बनाएको सामान्य उपकरणको प्रयोग गरिरहेको छु। म चन्द्रमाको एङ्गल अफ एलिभेसन निकाल्नका लागि यसरी चन्द्रमालाई क्यालेनोमिटरको ठिक सेन्टरमा ल्याएर आउनुपर्छ। ठिक सेन्टरमा ल्याएर आएपछि हामीले प्रोट्र्याक्टरमा आएको एङ्गल रिडिङ गर्नुपर्छ। एङ्गल रिडिङ गरिसकेपछि हामीले त्यो एङ्गललाई 90 डिग्रीबाट घटाउनु पर्ने हुन्छ, किनभने हाम्रो क्यालेनोमिटर अहिले होराइजनसँग 0 डिग्री अलाइन छ। 90 डिग्रीबाट 72 डिग्री घटाउँदाखेरि चाहिँ 18 डिग्री आयो। मैले यो 9:36 लिएको डाटा हो। यसलाई इन्टरनेटको डाटासँग तुलना गरी हेर्दाखेरि चाहिँ ठिक मिलेको छ। 18 डिग्री चाहिँ एङ्गल अफ एलिभेसन रहेको छ मुनको। अनि यसै गरी मैले सूर्यको पनि एङ्गल अफ एलिभेसन निकालेको छु। त्यसका लागि यसरी सेटअप गरेर सूर्यलाई पनि मुनको जसै गरी क्यालेनोमिटरमा अलाइन गरिसकेपछि हामीले प्रोट्र्याक्टरमा हेर्दाखेरि चाहिँ यसको प्रोट्र्याक्टरले चाहिँ कति देखाएको छ भन्दा 61 डिग्री देखायो। 90बाट 61 डिग्री घटाउँदा 29 डिग्री। यो बेलुका 4:34 लिएको डाटा हो। यसलाई गुगलको डाटासँग कम्पेयर गर्दाखेरि हाम्रो एक्युरेसी पर्सेन्टेज चाहिँ 97.32 छ र अनि इरर पर्सेन्टेज चाहिँ 2.68% रहेको छ। मैले बनाएको यो सामान्य उपकरणका सहायताले हामी 2वटा छड्के सतहको 49 कोण पत्ता लगाई उक्त सतहको उचाइ पनि सजिलै मापन गर्न सक्छौँ। अर्थात् यो उपकरण भौतिक विज्ञानको अध्ययनका लागि पनि उपयोगी छ। धन्यवाद।
After graduating grade 12 in 2024, I applied skills that I self-learned and got an internship at Robotics Association of Nepal. For the next 6 months, I worked on multiple projects and became more confident. And then finally, I decided to go to Mach 24 Orbiters, Nepal's first rocket company, to pursue my interest in astronomy and rocket science. I started in February 2nd, and as a CAD designer, I made multiple designs. I'm designing capacity were limitless. I worked on multiple projects that included launch rail for our 1 kilonewton rocket, which consists of base plate, extrusion rod, and rail button, which you can of course see in the screen. My other projects include vertical test stand and centrifugal machine. And for our vertical test stand, I was assigned to design a test stand which could withstand the force of our rocket, which is about 1 kilonewton. And considering certain factors, our test stands will be able to withstand the force of about 3 kilonewton just for the safety. And for this, I have used sheet metal and square iron rods for our fabrication of our test stand. And over here we have about this we have this sheet metal where our load cell will be attached to, and we have this deflector plate which is in an angle of 45 degrees just to deflect the thrust coming from our rocket. And for our cylinders, our two cylinders will be kept in these two rims of our two rims which is made of iron. And for our feed system, it will be kept just behind our rocket over here attached to this sheet metal. And that's about our all the assembly for our vertical test stand. For the base plate of our launch rail, I came up with this design after multiple iterations. Which this final design consists of multiple holes for launch angle. So, for example, for 90 degree of launch angle, this hole will be used to construct any movement, and for angles less than 90 degree, these multiple other holes will be used. So, for the final assembly, it will end up looking like this. So for the sake of scale, our rocket is about 4.7 meters. So these nut and bolts will be used to construct any movement, and for angles, these bolts will be used. And finally, our setup is complete. Also, X bolt and nuts are used to keep our rocket in a fixed position. During the test fire, the live data is saved to an Excel file in an SD card. Then the data is later used to plot different graphs. The code that is seen on the screen plots graph for the specific impulse. The way this code runs is that first this code reads the Excel file named rocket underscore data. Then it extracts all the relevant columns which are time, thrust, and mass flow rate. After that, these parameters are inserted into the specific impulse formula, which is thrust upon mass flow rate. And then, using Python's matplot library, it plots all those data into a which contains maximum and minimum value of the specific impulse.
Hello, the Telescope Club. My name is Siddhant Parajuli and I am the Vice President of Astronomy Squad of Kosi and Astronomy Mentor at the Squad of Changemaker. I am sending this video to you because I need a telescope to support my work in astrophotography and astronomy outreach. Currently, I am using a 50AZ homemade telescope which I have been using from past year. However, I now need to upgrade to a new one to improve my quality in astrophotography and astronomy outreach. Over the past year, I have been involved in the field of astronomy and discovered 19 preliminary asteroids and also trained lots of students about asteroid search campaign and hosted an international asteroid search campaign. In addition, I regularly give a lecture on telescope and astronomy during workshop to educate and inspire others in the field of astronomy. These are some of the contributions that I have done to promote astronomy, and I hope this video gives you a good sensation of my passion and commitment. At last, here are some of the photos that I have clicked using my 50AZ telescope. Thank you, the Telescope Club.
Namaste, my name is Subhas Ayedi and I am a student deeply passionate about aerospace engineering and future of rocket science. Today, I want to share a dream that begins in the heart of Nepal, a dream to see a Nepali rockets land on the moon. In Nepal, we are not strangers to the hard work and perseverance. From the towering peaks of the Himalayas to the bustling streets of Kathmandu, our people have always dreamed big. Today, that dream takes the shape of the rocket built not in a high-tech lab, but in the humble surroundings of our temple people, schools and universities. With limited resources but unlimited determination, Nepali students and engineers are coming together. Every nurse, every bolt, every piece of this rocket is a testimonial to our collective effort. We may not have the wealth of other nations, but we have something else even more powerful, our unity and our belief in the impossible. After years of hard work, the day have finally arrived. The rocket stands tall, ready to carry the hopes and dreams of entire nation. This is just not a mission. It is a symbol of what we can achieve when we work together. And there it goes, our rocket, carrying the private Nepal soared into the heavens. This is not just a journey to the moon. It is a journey of our spirit, our resilience, and our unyielding belief in ourselves. We did it. The Nepali flag now flies in the moons, a testament to our hard work and determination. This is a moment of pride for every Nepali, a moment that proves that no dream is too big, no goal is too far. Back home, the streets are filled with celebration from the youngest child to the oldest elder. Everyone is filled with pride. We have shown the world that even a small nation like Nepal can reach for the stars. But as I wake up, I realize it was all a dream. A dream one day Nepal will land a rocket on the moon. A dream that one day our flag will fly among the stars. And until that day comes, I will keep dreaming, keep working and keep believing. Because in Nepal, we know that dreams are the first step towards reality, and one day we'll make this dream come true, Nepal.